By 2030, reaching Spain from the North African country by train could be a matter of just over 5 hours. Now, this implausible connectivity could be achieved through an underwater rail tunnel that would link the continents of Africa and Europe. Recent high-level meetings between Spain and Morocco. Now, the project would involve constructing two 28-kilometer-long underwater submarine tunnels beneath the Strait of Gibraltar.
The ferry leaves Tarifa at dawn. Tarifa is a small port town in southern Spain. A port is a place where ships load and unload. In front of the bow, the sea is dark and fast, and the wind can change in minutes. In about 1 hour, the ferry can reach Tangier in northern Morocco. That feels shocking because this short water gap separates Europe and Africa. At the narrowest point, the two coasts are only about 13 kilometers apart. That is shorter than many daily drives to work. But the same wind that makes the sea rough also shows the problem. Some days, waves stop the boats, and the easy crossing becomes a delay and a long wait. People sit with suitcases, trucks line up, and the clock keeps moving. So the question keeps coming back. Can we make a crossing that does not depend on the weather? This is where the tunnel story begins. Not a tourist tunnel, and not a small local project. A giant rail tunnel under the Strait of Gibraltar could become a fixed link. A fixed link is a permanent crossing, like a bridge or a tunnel, that stays open in most weather. The headline number can sound wild, even $300 billion. But there is no single official price tag that everyone agrees on. Some studies count only the tunnel. Other studies also count new rail lines, border stations, and the cost of borrowing money. What is clear is simpler. Even the smaller, public estimates are still huge. If it ever happens, the tunnel would not just save time for a few travelers. It could change trade, jobs, and power on both shores. And it would force hard choices about borders, rules, and who gets to move quickly and who does not. That is why this project is exciting and also explosive. Look at a map, and you can see why this strait matters. The Strait of Gibraltar is a narrow sea path between two lands. It is the door between the Atlantic Ocean and the Mediterranean Sea. Many ships pass through this doorway every day. Now zoom in on what sits just south of the strait, Morocco's port region near Tangier. Trade links there keep growing, and they connect into European supply chains. Supply chains are the step-by-step path goods take from maker to buyer. A tunnel would not replace ships, but it could change which routes feel fast enough for business. North of the strait, the other side plugs into the huge European market. In 2024, trade in goods between the European Union and Morocco was about 60.6 billion euros. That is money moving as cars, parts, food, and textiles. Today, almost all of the crossing is done by ship and then by road. A tunnel could pull some of that movement onto rails. Rail is the train network. Trains can move many tons at once, with less waiting at sea. But only if the tunnel connects to strong rail lines on both sides, and only if the rules at the border do not turn every train into a traffic jam. A tunnel would also change the last-mile problem. The last mile is the final short trip from a big transport line to the exact shop or factory. Today, trucks roll off ships and drive onto roads. With rail, you need yards, cranes, and clear schedules, or the line clogs up. So the tunnel would only feel magical if the land networks around it are upgraded too. This tunnel idea is not new. Spain and Morocco made it official in an agreement signed on October 24, 1980. The agreement set up a joint committee to guide the project. It also pushed both countries to create study companies to do the technical work. In Spain, that study company became Sesegsa, created on February 26, 1981. In Morocco, the partner is SNED. Their job is not to dig the tunnel tomorrow. Their job is to study the ground, the sea, the risks, and the best route, again and again, as tools and politics change. Over time, the studies kept running into the same hard fact. The strait is short, but it is not simple. The seabed drops fast. In some places, the water above a tunnel line can be very deep, hundreds of meters. So the shortest line is not always the smartest line. Engineers began to talk about two main options. One option is shorter, but much deeper. Another option is longer, but it stays over shallower seabed, closer to about 300 meters in key spots. Either way, shallow here still means deeper than most skyscrapers are tall. For a tunnel like this, cut and cover will not work. Cut and cover is when you dig a trench, place the tunnel, and cover it. That method needs shallow water. Here, much of the seabed is far too deep for that. So the main plan is boring through rock under the seabed. Boring means drilling a tunnel, not being dull. The tool is a tunnel boring machine. A tunnel boring machine is a giant drill that chews through rock and soil. Now compare this to the Channel Tunnel between Britain and France. The Channel Tunnel is about 50.45 kilometers long, with about 37.9 kilometers under the sea. It uses 2 rail tunnels and a service tunnel. A service tunnel is a smaller tunnel used for safety and repairs. The Channel Tunnel is a world-class achievement, but the Strait of Gibraltar raises the bar. In the Channel, the tunnel reaches about 75 meters below sea level at its deepest point. In Gibraltar, the seabed can be hundreds of meters down, and the tunnel would need to go deeper than the seabed to stay inside stable ground. That means longer ramps, more drilling, and more places where water pressure can cause trouble. There is also water pressure. The deeper you go under the sea, the harder the water pushes on every crack. That pressure can force water into weak layers of rock. So engineers have to find ground that is strong enough, and they have to seal the tunnel with extreme care. Then there is the strait's strange 2-layer flow. Near the surface, Atlantic water tends to flow into the Mediterranean. Deeper down, saltier Mediterranean water flows back out into the Atlantic. This constant push and pull is real ocean science, not just a tide chart. Even the shallowest sill in the strait is deep. A sill is an underwater ridge that acts like a shallow step. The Camarines sill is about 284 meters deep. That sill helps shape the strong water exchange that makes the strait so busy and so rough. And then comes the ground itself. This region sits near the meeting zone of the African and Eurasian plates. A plate is a giant moving slab of Earth's crust. When plates push, they can make earthquakes, and even small shaking matters when you plan a long tunnel. That is why recent work has focused on updated seismic studies. Seismic means earthquakes. Spain's study company has described renting seismometers to measure shaking over time. They want months and years of readings, not a quick snapshot. This is the slow, careful homework before any real digging. Now shift from rock to rules. A fixed link makes it easier to move goods. It can also make it easier for people to cross if the border system is weak or overwhelmed. That is why immigration politics sits like a storm cloud over this idea. Spain has 2 small enclaves on the African coast, Ceuta and Melilla. An enclave is a piece of a country surrounded by another country. These borders are part of the European Union's land border with Africa, and they are heavily watched. They show how sensitive and political a short crossing can become. Frontex tracks how routes change over time, including routes towards Spain. When pressure rises, governments tighten rules. When pressure falls, the argument does not disappear because it can rise again. Any new easy crossing would be judged inside that bigger border picture. So a tunnel would force a hard promise, fast for trade, but controlled for people. That means border checks, patrols, and agreements between countries. It also means constant arguments about who pays, who decides, and who takes the risks. If politics breaks down, a tunnel can turn from a symbol of connection into a symbol of fear. For decades, the tunnel sounded like a dream. But Morocco has changed fast in ways that can make the business case stronger. One change is big ports and industrial zones near Tangier. Another change is growing links to Europe in cars and parts, which now show up strongly in trade data. A second change is rail inside Morocco. Morocco built its first high-speed rail service, which links the country's north with major cities. High-speed rail means passenger trains that run much faster than normal trains on special tracks. When more people and goods move quickly inside Morocco, a fast door to Europe starts to look more useful. A third change is energy plants, especially green hydrogen. Green hydrogen is hydrogen made using clean electricity, not fossil fuels. Morocco has promoted big plans for renewable power and for exporting new energy products. Europe has also talked about getting more clean energy from nearby partners. So where does the tunnel stand today? The safest answer is, still in study mode, but not dead. Spain has continued agreements and cooperation around the study work. A project can be alive for years in this stage, because the ground truth is hard to get. Spain has also put real money into updated work. A 2023 public contract linked to recovery funding listed about €2.3 million for work connected to the fixed link studies. That is not tunnel money. It is to measure the problem money. Media reports in Spain say that both countries have already spent over €100 million over decades on the study companies and studies. That does not build a single meter of tunnel. It pays for surveys, research teams, and test plans that reduce guesswork. But it does build maps, seismic records, and route plans that make the next decision possible. When it comes to the tunnel's final cost, estimates vary a lot. One report says the 2007 plan was priced around €10 billion back then, and around €15 billion when updated to 2024. Those numbers can change with inflation, design choices, and safety rules. Other public discussions suggest different ranges and even debate the tunnel length itself. This is why $300 billion is best treated as a warning sign, not a fact. Big numbers often come from adding many side projects onto the tunnel story. If you add everything that must change around the tunnel, rail links, power, security, border stations, and long financing, the number can climb toward the size of a small country's yearly budget. But the tunnel itself, as described in public estimates so far, is usually framed in tens of billions, not hundreds. And even if the engineering works, the tunnel is still a political bet. It needs long-term trust between Spain and Morocco. It needs buy-in from the European Union. And it needs rules that make trade smooth without turning human movement into chaos. So the real question is not only, can we drill through rock? The deeper question is, can two continents agree on how a new door should work? That door would need rules that feel fair on both sides. It would also need safety plans that people trust in an emergency. If the answer is yes, Europe and Africa become neighbors in a new, physical way. If the answer is no, the ferry keeps leaving at dawn, and the dream stays under the waves.